Why is the ozone hole sometimes bigger than North America? Imagine a giant hole in the sky over Antarctica that can stretch across millions of square kilometers, sometimes bigger than North America itself. That's what scientists call the ozone hole. It's a huge area in the stratosphere where ozone levels drop way below normal. But why does this happen, and why does it sometimes grow so large? To understand, we need to look at some special conditions around the South Pole that make this possible. During the Antarctic winter and early spring, a strong wind pattern called the polar vortex forms around the continent. This vortex acts like a giant barrier, trapping cold air inside and stopping it from mixing with warmer air from lower latitudes. Because of this, the air inside the vortex gets extremely cold, often below -78 degrees Celsius. These super cold temperatures lead to the formation of polar stratospheric clouds, or PSCs. These clouds are key because they provide surfaces for chemical reactions that turn harmless chlorine and bromine compounds into reactive forms that can destroy ozone quickly once sunlight returns. When spring arrives in the Antarctic, sunlight hits the region again. This sunlight triggers chemical reactions on the PSCs, releasing chlorine and bromine atoms that attack ozone molecules. Because the vortex keeps the ozone-depleting chemicals concentrated in one area, the destruction happens on a massive scale. The result is an ozone hole that can reach over 20 million square kilometers, which is about 3 times the size of the United States. The geography of Antarctica also plays a role. It is a large landmass surrounded by ocean, which helps stabilize the polar vortex and makes the ozone depletion more persistent and widespread. In contrast, the Arctic, which is more complex in shape and less stable, usually has smaller and less persistent ozone holes. Every year, the size of the ozone hole changes depending on how cold the stratosphere gets and how strong the vortex is. Since the late 1900s, international efforts to cut down on chemicals that harm the ozone layer have helped reduce the size of the hole. But under the right conditions, it can still grow very large. So, the reason the ozone hole can sometimes be bigger than North America is because of the unique atmospheric conditions around Antarctica. The cold temperatures, the stable polar vortex, and the presence of PSCs all work together to create a perfect storm for ozone destruction. This natural laboratory shows us how human-made chemicals can cause big changes in our atmosphere and why protecting the ozone layer is so important for life on Earth. Monitoring these changes helps us understand how well our efforts are working and what more we need to do to keep the ozone layer healthy.